Hello students, now we are looking at how to calculate mode using formula. When you were in SS1, you were taught to calculate mode using the histogram. That means you used histogram to find the mode to find the mode. But now we want to learn to use to calculate mode using the formula. So this we can use this formula to calculate the mode. Mode is equal to L plus D1 over D1 plus D2 times C, where your L represent the lower boundary of the modal class. Your D1 is the frequency of the modal class minus frequency of the class immediately before the modal class. So frequency of the modal class minus the frequency of the class immediately before the modal class. Then D2 represent frequency of the modal class minus frequency of the class immediately after the modal class. C represent the width of the modal class. The width of the modal class. To be able to buttress on this, let's consider this using this example. Now, the question says the table below gives the distribution of marks of 100 candidates in a mathematics examination. So these are their marks range. Those that we having 10 students scoring between 11 to 20, 21 students scoring between 14 students scoring between 21 to 30%, 17 students scoring between 31 to 40%, then 22 students scoring between 41 to 50%, 19 students scoring between 51 to 60%, then 9 students scoring between 61 to 70%, and 9 students again scoring between 71 to 80%. So use your table to find the mode by formula. So before we can do this, we must first of all get the table. So we have the marks range, which is from 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80. Then the frequency has also already been given. So we having 10, 14, 17, 22, 19, 9, 9. When you add everything under the frequency, you having 100. So for us to be able to use the formula, you need to know the class boundaries. So how would you get the class boundaries? The lower class boundary, from this 11, you subtract 0.5. When you subtract 0.5 from 11, it will give you 10.5. And you now add the 0.5 to this 20. So 20 plus 0.5 will give us 20.5. 21 minus 0.5 will give us 20.5. 30 plus 0.5 is 30.5. 31 minus 0.5 is 30.5. 40 plus 0.5 is 40.5. 41 minus 0.5 is 40.5. 50 plus 0.5 is 50.5. 51 minus 0.5 is 50.5. Then 60 plus 0.5 is 60.5. 61 minus 0.5 is 60.5. 70 plus 0.5 is 70 plus 5. 71 minus 0.5 is 70.5. Then 80 plus 0.5 is 80.5. So you get the class boundaries. Then after this, let's try to get the parameters. The formula says you are going to use the mode is L plus D1 over D1 plus D2 times C. So that means we need to know the value for our L. So coming back to the definition we gave earlier, we said the L is lower boundary of the modal class. Lower boundary of the modal class. So from this table that we are given, we can easily know the modal class. When you talk of the mode, the one with the highest frequency. So you come to the frequency column, which is the highest value here. You realize that the highest value here is what? 22. So 22 is the highest value. So that means the modal class is what? This is where the mode is going to be between 41 to 50. So now that means you are going to say what? Our L represent the lower boundary of the modal class. So realize that this is the lower boundary of the modal class here is what? 40.5. So 40.5 is the lower boundary of this modal class. So that means our L represents 40.5. So when you look at the one with the highest frequency, then you look at the class boundary. This is the lower class boundary, upper class boundary. So the lower class boundary of this modal class is what? 40.5. So L represents 40.5. Then what do we need again? We need to know our D1. Our D1 is what? Frequency of the modal class minus frequency of the class immediately before the modal class. So realize that this is the modal class. The frequency of this one is what? 22. Then the frequency of the class before it is this 17. So you now say 22 minus 17. So that is how we got the D1. So it will be what? 22 minus 17. 22 minus 17 will give us 5. Likewise, our D2. Our D2 is frequency of the modal class minus frequency of the class immediately after the modal class. You realize that the frequency is the modal class. The frequency is 22. The frequency of the class after it is what? 19. So our D2 will now represent what? We will now say 22 minus 19, which is give us 3. Then the class width. So the class width will be you find the class width by subtracting the lower class boundary from the upper class boundary. So 50.5 minus 40.5. 50.5 minus 40.5 will give us 10. If you pick any of the class boundary here, it's going to give you what you wanted. So that means 40.5 minus 30.5 is what? 10. So from here, you are now going to substitute these parameters in the formula. So the formula for the mode is L plus D1 over D1 plus D2 times C. So our L, which is the lower class boundary, is 40.5 as we have checked earlier, plus our D1 is 5 over D1 plus D2, that is 5 plus 3, then everything times 10. So we are having 40.5 plus 5 divided by 8 times 10 will give you 6.25. When you now add 40.5 and 6.25, it will give you 46.75. So for the work practice, you are going to do this. You are having the following are the marks in percentage of the 40 candidates in an examination, just like the one I gave you in the last exercise. 12, 36, 38, 6, 17, 46, 39, 5, 16, 28, 47, 45, 38, 64, 36, 44, 14, 24, 15, 29, 12, 27, 57, 58, 48, 26, 39, 23, 37, 36, 29, 36, 12, 15, 42, 28, 15, 52, 28, 82. So A part says draw a frequency distribution table using equal intervals of 5 to 14, 15 to 24, like that till you get to 875/24. Calculate the mode using formula. So you're expected to calculate the mode this time using formula. So for the second one, the table below gives the masses in kilogram of 100 job seekers who reported at the Directorate of Employment Center in a state. So this is their masses. Again, the number of job seeker 50 to 44 we have 10, 55 to 59 20, 60 to 64 that's 23, 65 to 69 15, 70 to 74 11, 75 to 79 6, 80 to 84 that's 5, 85 to 89 3, 90 to 94 that is 7. Use the formula method to calculate the mode of the distribution. You are expected to use formula to calculate the mode of the distribution. For the last part, the table below shows the distribution of masses of 100 blood donors. So we have the masses and their corresponding number of donors. So from 60 to 64, 62 kilograms we have 5. Between 63 to 65 kilograms that's 18. 66 to 68 kilograms that's 42. 69 to 71 kilograms that's 27. 72 to 74 kilograms that is 8. So use the formula method to calculate the mode of the distribution. You are now expected to use the formula method to calculate the mode of the distribution. Please ensure you like, subscribe and comment on this video. Thank you.